Okay, hi guys. So in this lecture, we'll be comparing rates of ozone layers on two nucleophiles. Okay, first question we are handling that. So we have to compare the rate here. So we have something like this, and you have to compare this rate of ozone layers among these three compounds. Okay, what would the rate of ozone layers? So more nucleophilic the alkene, more is the rate of reaction, because in ozone layers only alkene is going to attack on the ozone molecule. Okay, hence in this case there are more number of plus I groups attached to this, hence it would be having more rate of nucleophilicity towards, or rate of reaction towards ozone. And we have already seen that this compound is actually more stable than this, hence this would avoid going into the nucleophilic reactions with ozone, hence the rate would be something like this. So do you have any question on why? If you have any question on as to why this is more stable than this, then we have actually discussed this example in our past set of video lectures, so you can go and watch it there. Okay, so this will be the rate of reaction towards ozone layers. Okay, let's move on to the next example. So we have something like this. Okay, and this is undergoing ozone layers in presence of zinc. So we'll be getting deductive ozone layers, in which we'll get something like this. And if we get O3 in presence of H2O2, we'll be getting ketone would be same, and we'll be getting CH3 CO2H. Okay, let's look at second example. We have and CH3 here. Again ozone layers in presence of zinc, so we'll be getting something like this bond would be broken, this bond would be broken. Okay, so we'll be getting something like CH3 CH double bond O for this compound, or for this part. Next, for this part we'll be getting something like this, and for the last part we'll be getting the same product. So I'm just writing 2 moles here. So this is an example of oxidative ozone layers, or rather reductive, not oxidative, reductive ozone layers. And what happens when we react it with, again, O3 in presence of peroxide or H2O2, we'll get 2 moles of CH3CO2H for this group, and again we'll be getting CO2H and CO2H for this group. So this is an example of oxidative ozone layers. Okay, let's look at third example, wherein we have something like this, which on reaction with first hot alkaline KMnO4. Okay, and second we are passing some acidic medium, so we'll be getting something like this bond will be breaking up, and we'll be getting, as KMnO4 is a very good oxidizing agent, we'll be getting carboxylic acid. Okay, now we are passing something like hot alkaline KMnO4 on this compound, so what we would be getting, and again secondly we are passing H plus. So what we'll have is this CH3 would evolve as a CO2 gas. Okay, and we'll have a carboxylic acid at this position, so we'd have OH and CO2 gas evolving at as the side product. Okay, let's look at fifth example. We have something like this compound here, and in reaction with hot alkaline, again KMnO4. Okay, what is the product form in this case is, we'll be getting something like, again this carbon would be breaking up, and as a result we'll be getting something like carboxylic acid here, and here as well. Okay, let's look at another example. We are passing this compound in again hot alkaline KMnO4. Let's see what would be the product. So for this CH3, CO2 gas would be evolving. Okay, just redraw it, CH3 For this CH3, CO2 gas would be evolving. For this carbon, it would be converting itself into, or rather KMnO4 will be converting that into CO2H, and for this CH3 as well, it will be converting it into CO2H. Let's look at this compound. We have C4H6. You have to identify the exact structure of this compound. We are passing oxygen, or rather we are doing ozonolysis, and we are getting something like HCHO plus CHO. What would be the product A? It would be something like this, 2 moles of, yeah. So now 2 moles of HCHO would be from first and fourth carbon, and while 2 CHO attached with each other will come from this group. Okay, let's look at the last example for this lecture. We have organic compound A, which on reaction with again ozonolysis forms ketone plus CH3 CO2H plus CO2H and CO2H here. Okay, so what would be the compound A? We have to just guess it, that it has to necessarily have CO2, means double bond carbon definitely should be here, because ketone group would be formed, otherwise no ketone group would be formed. Okay, next we have to think that two attached CO2H would be there only in case when we can have something like this product. Okay, so we can have 1 mole of rather we should have double bond here, because CO2H would be formed in that case only. So we'll have something like double bond here and double bond here and CH3 here. Okay, so what will it form is, so on ozonolysis will it form this product. So we would be actually getting 2 moles of CH3 CO2H if we took this compound. Okay, why? Because if this bond breaks, firstly we'll be getting this, secondly we'll be getting CO2H here and CO2H here, and when this bond breaks we'll be getting this compound. Okay, so you have to just make the compound and guess whether we'll be able to get all the products here or not. So the reason we have 2 bonds on alternate positions is because we saw that 2 CO2H attached to each other has to be formed, and hence 2 attached CO2 can be formed only by this configuration. Okay, so with this configuration 2 moles of CO2H can be formed. Next we have to see how this CH3 CO2H would be formed. So if we have a carbon here and a CH3 group here, this CH3 CO2H would be formed because this would be ozonolized. Okay, next we have to see how this product has to be formed. So we should have something like a ring here, because on ozonolysis it would be forming a keto group over here. So this is how we derived the product. So you have to just make the product by going in the reverse direction, and then you will get the desired answer. Okay, so obviously if we have not mentioned and we are getting CO2H, it is obviously in presence of H2O2, and in the above example if we are not mentioning and we are getting products such as CHO, then obviously this would be in presence of zinc. Okay, so I hope you understood the lesson, and in the next lecture we'll be taking on Kc and Tc, which is nothing but kinetically controlled and thermodynamically controlled reaction. Okay, so with this we come to an end of this lecture. So we'll meet in the next lecture with so good luck and goodbye till then.